All right, this is question number 6 from lesson 4, and it says that A and B are unit vectors, and they're at an angle of 60 degrees with each other. They want you to calculate the magnitude, that's what that means. So we're looking for the magnitude. So what I'm going to do, I'm going to do question A. I'm going to do it both algebraically and geometrically so you can see both, and then you can try B on your own. So let's start with algebraic. All right, so with algebraic method, we have both vectors centered at the origin. So I'm going to put the A vector. Let's make that a little larger. So there is my A vector. All right, 3A, so that means it's 3 units in length. And B vector, I'm going to put up here, 5B, and they're at an angle of 60 degrees to each other. All right, so when you do it algebraically, we do the stacked method. So we would do 3A would equal 3I, because it's 3 units long, and plus 0J. Next one is we're going to do subtraction. So we're going to subtract 5 times the B vector. So the B vector, as it's drawn here, all right, is 5 units long, cos 60. So that will give me my x component for that vector, plus 5 sine 60j. And that gives me the y component for that vector. All right. So, using the calculator now, we can go ahead and calculate it. And remember that we are subtracting those values. So we have 3 subtract 5 cos 60. And I end up with 0.5i. And the other one, 0 take away 5 sine 60. And I get negative 4.33. Okay. Now from this point on, you kind of go into cruise control. Your magnitude of your resultant is the square root of 0.5 squared plus negative 4.33 squared. So plugging that in, squared plus 4.33 squared, all square rooted. I get a magnitude of 4.3, let's call it 36 units. My angle is the tan inverse of my y component over my x component. So shift tan 4.33 divided by 0.5, 83 degrees. So therefore, the resultant is 4.36 units. And going back to my equation, the x component is positive, so it's going to head east, 83.4 degrees, and that component is a negative, so it's going to head south. So there is the answer using the algebraic method, and if that's the method you're comfortable with, obviously this is where you can kind of quit at this point and move on. I'm trying to group here. All right, now that I got that shrunk, I'm going to do the geometric method. Like I said, if you're comfortable with the algebraic method, you're probably going to do it that way, so the geometric's not going to be overly helpful. However, for the algebraic method, it's that picture that trips everyone up. So, again, starting off with 3A. Now here is the trick. I'm going to draw it in green. That is 5V at a 60 degree. Now keep in mind, and what's very important here is that we are doing 3A minus 5B. So now I got to really switch that green vector around and make it negative, so it's actually facing down in this direction. So there's my 5, oops, that should be B, 5B, which means that that 60 degree angle, opposite angle theorem, that's going to be 60 degrees in there. which makes it a little bit easier because now I don't have to go searching for that internal angle. So there we go. There's the diagram that we're going to use. We're looking for that resultant. So now we can go to our cosine law. So the magnitude of the resultant is the square root of 3 squared plus 5 squared minus 2 times 3 times 5 cos 60. We'll plug that into the calculator, and we know we're going to get hopefully around the same answer we did before. So let's see what I get here. I know you're sitting there in eager anticipation. I get square root, hey, 4.36, that's a good sign. All right, so there is your magnitude of the resultant. Now, using the geometric method, you're going to use sine theta over, and the theta I'm looking for is at the tail of the resultant. So this is what I'm looking for. So sine theta over 5 equals my resultant. Oops. So it'd be sine 60 over 3. So sine theta equals 5 sine 60 over 3. So calculating that, 5 times sine 60, divide that by 3, and that's a problem. It only gives me 1.44. So what did I do wrong here? Oh, I see my mistake. You're probably seeing it as well. Sine 60 is across from the resultant, so that's not right. So it should be sine 60 over the resultant, which is 4.36. So that will make the math a little happier. My calculator wasn't too impressed with that. 5 times the sine 60, divide that by 4.36, and we'll take the inverse sine of my answer, and 83.3 degrees. That looks pretty familiar. So in this case, it's a little bit different. You're going to report the resultant from its location compared to vector A. So for geometric, you're going to say the resultant is 4.36 units, and you are clockwise. We went that way, so we are 83.3 degrees clockwise from A. All right. So there we go. There's your two methods side by side. You only have to do one. You pick the one that makes the most sense to you. I would recommend, for those that are continuing in university, in a physics engineering program, the algebraic method is really what's going to be used a lot. For those that are going into your health sciences and so on and so forth, it's not going to really matter which one you pick as long as you're comfortable and good with it. So hopefully that answers some questions. If you do have any other questions, let me know.